Everyone, in this video, let's discuss this problem Koko eating bananas. The problem statement is Koko loves to eat bananas. There are n piles of bananas. The ith pile has piles of I bananas. The gods have gone and will come back in H hours. Coco can decide her bananas per hour eating speed of K. Each hour, she chooses some pile of bananas and eats K bananas from that pile. If the pile has less than K bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly, but still wants to finish eating all bananas before the god return. Return the minimum integer k such that she can eat all the bananas within hours. So basically this problem involves like a we need to calculate the speed, but what kind of speed we need to calculate here, that we need to think. But whatever we are finding calculating the speed rate, the speed will range, and that range we will do a search. I'll give an example here. Suppose you have an exam, so you need to come to the exam hall within an 8 hours. So your bike have a constant speed. So suppose you have 2 kilometer per hour and you have 4 kilometer per hour. So in this case, if you chosen this right, you can come in 4 hours. But whereas if you come in 4 kilometers per hour, you can just come in 2 hours itself, right? But the just what I given, we need to come within 8 hours. So this was the case. So you need to find the minimum. You need to find here minimum speed such that you can come in a 8 hours. So the thing is you can start from 1 kilometer per hour, and you can start in. So you need to suppose if you come in 1 kilometer per hour, so it will take, you need to so it will take, it's like where you can start, you need to start from the speed. You can start like 1 kilometer per hour to, you can try with the 2, you can try with 3, 4, 5, 6, like that you can keep. Suppose if you come in 8 kilometer per hour, you can simply come in 1 hour. So it's like that, the problem statement is like that. We'll discuss the problem statement now. So the cave Coco loves to eat bananas. There are n piles of bananas. Suppose there is a first pile, there is a second pile, there is a third pile, there is a fourth pile, there is a fifth pile. Let's take like that. Suppose first pile have 3 bananas, and second pile have 6 bananas, and third pile have 7 bananas, and fourth pile have 11 bananas. So what happens, right? Coco can decide her bananas per hour eating speed. Like it's like how many bananas you can complete per hour. Like it is like eating speed of k. So he needs to decide her bananas per hour. So how many, suppose you just decide, I'll just complete 3 bananas per hour. So here it will come 1 hour, here it is come 2 hours, and here it is come again so 7, right? 3, 3, and again one pile will left, so again you need to spend 1 more hour for this. and the fourth similarly. But the thing is, she chooses some of the pile of bananas and eats k bananas from that pile. So, like I said, k bananas. If the pile has less than the k bananas, she eats all of them instead and will not eat any more bananas during this year. This is the thing here. Suppose you eat here, suppose 7, you eat you chosen 3 bananas per hour, you eat 3 will be left, again there will be 1 little left. So in this pile, the one you need to complete first the pile completely, you should not go to another pile. That was the case. Coco likes to eat slowly but still wants to finish eating. Suppose if you just choose like 1 banana per hour, what happens? 3 9 here itself you are exiting the exit. So that time, so that's why you need to choose the minimum time, minimum eating speed. So maximum you can choose 11 itself, so you can complete each, but you want to choose the minimum. So that was the problem statement. So what was the idea is, first thing is the time, where we'll start. Like let's start with the 1 banana per hour, and the speed, let's try from this speed to, let's try maximum speed. What is the maximum speed? Find the maximum pile in that array. Suppose see, 11 is the maximum, so if you take the 11 speed, you can complete 1 2 3 4 4 hours. But the thing is, you need to find minimum speed, not maximum speed. So first you will find the so this is, you can try from 1 speed to 11, try with everyone. Suppose try with 1. So what you will do, so you chosen 1 banana, so just tag. So if you choose 1 banana, 3 hours and 6 hours, it is exiting, try with the 2. So whatever you try to increase the speed, that minimum speed, try with 1 2 3 4. Suppose if 4 is working, suppose if the 4 is working, just go ahead with 4. That's it. So let's discuss this the code. This was the approach. First, let's discuss here. First, find the biggest pile. So the pile, biggest file is in the piles, right? Just try to take, if the pile is the greater than max pile, that means like in the piles, right? Take the maximum value. That's it. And try every possible speed from speed 1 to with the maximum pile. And now we need to calculate the hours. First, take, so here from each pile, take the pile and enter hours, pile per speed, right? Suppose I saw here the example, there is a 7 piles. So suppose if you take and choose 3, so you will get 2, and you will let one more 1, right? So whenever if you get the decimal part, you will add one more hour, and just calculate all the hours. And for whenever you get the minimum speed, you just return that speed. So this was the code. I'll try to run. So what is the problem here? If I write this a brute force, I can run definitely, but the problem is the constraints. So you are checking the pile length is 1 is less than piles dot, the piles dot value is here, we need to choose the value, right? 10 power 9, so you're going to the 10 power 9. So that's why if you try to submit, right, you will get the time complexity issue where you will get time limit exceeded. It will work, the code will work, because we run in a linear search. We are trying to search from speed 1 to maximum pile speed, and we are trying to calculate total hours, and whenever the total hours less than our target time, we are returning that. So instead of calculating the speed 1 to max pile, right, just take binary search. What you will do here, binary search, instead of taking here, so like here the speed 1 to max pile, right, just take like a binary, like left and right. The left is you start with 1, the right speed is maximum is the max pile length. And whenever you found the value, if the value is less than you like we know the rule of binary search, right? Whenever the value is the found value is less than the left part of it, suppose this is the left, this is the value, and this is the right. Whenever the value is just greater than left, it's greater than left, so but is less than right, right, it will come here. If the value is like greater than right, I'll show you that here. So the brute force approach, the thing is same, the left is 1 and the right you're finding the maximum pile. The binary search, left is less than or equal to right, and you will finding the mid value. First you will take the mid, and you will just keep on rotating that mid. Total hours and the piles, suppose you take first mid as a middle value. So whenever you get that middle value, right, so some hours, that some hours is less than or is equal to hours. Like if it is already less than, what you will do, you just to do the right as a mid minus 1, just try a value before it, or else lft equals to mid plus 1, so just increase here. It's like I just discussed, right, left and mid and right. So if you found the value here, the total hours is less than is equal to hours, that means you need to decrease the right. So whenever the point comes decrease, you will come as the right, just like you will take mid minus 1, somewhere you will keep it right here, and again you will search in middle value. So it's all about just binary search. I'll take, so the Coco Eating Bananas mainly it is a kind of advanced binary search. It's not straightforward binary search. Let me run this code. So yeah, it will accept it now. Yeah, so I've just taken the same thing. Instead of counting the speed, I'm taking a binary search, the left as 1, right as max file, and try to calculate a total hours. The total hours, if it's less than my hours, I'll just move to the left side. If it is greater than right, I'll move to the value as a right side. But here whenever you found the right value, uh, automatically the value will stop, and whatever we got the value, right, because the left, whatever we got the value of the left, right, we'll just return it. That's it.